Hello and welcome to this Formlabs webinar. This is a shortened version of the original broadcast. If you'd like to view the content in full, please click on the link below.
Yeah, good morning. Thanks for being here, everyone. This is our webinar we're doing with PO3D. This is the first in a series of webinars we're doing about product development and product design. We're sort of doing this webinar series in order of how you'd be working as you design a product. So from scan to final product, and naturally we're starting with scan. We've done some work with PO3D before. They've been an absolute pleasure to work with, and we're excited to do more. My name is Dan Kirschgessner. I'm joined by Jose from PO3D. He'll do his intro in a few minutes when we get to his section, but thank you so much, Jose, for being here again. So yeah, we'll start with the agenda here. Apologies for the siren outside. A quick welcome, just some Zoom housekeeping really quickly. We'll do an overview of Formlabs products and sort of what we do and materials and printers and things like that. Jose will then do something similar for PO3D with hopefully a little live demo of scanning as well, which will be awesome. And then at the end, we're hoping to have 10 to 15, maybe 20 minutes or so of time for question and answer. So with that, we'll get started. My name is Dan Kirschgessner. I'm the Community and Partnerships Manager here at Formlabs. I've been with the company around 6 years. I started on our services team in 2016. Then around 3 years ago, I jumped over to marketing and have been doing that ever since. Formlabs is a 3D printer company that's been around since around 2011, 2012. We started on Kickstarter. We've been, full 10 years now, which is really awesome. And we've got quite a robust product line at this point, mostly splitting between two main 3D printing technologies, stereolithography or SLA, and selective laser sintering or SLS. I'll give a quick overview of both these technologies, but all Formlabs printers fall into these two buckets. The other machines here, I'll just add on, if you're not aware, are part of the kind of printing ecosystem of these machines. So the wash and the cure, either the little ones or the big ones for the SLA, and then the sift is the post-processing solution for the Fuse 1. So SLA, a lot of you are probably aware, but for anyone who's not, SLA stands for stereolithography. It's using a UV laser to turn a liquid resin into a solid plastic. We've been iterating on this technology in a lot of different ways throughout the years. The main iteration on our most recent printer, the Form 3, is what we call LFS, or low force stereolithography. If you're aware of SLA, you might know that a big part of the printing process is that you're essentially gluing the part to the bottom of the tank on each layer, and that part needs to become unglued during the printing process. So on our older printers, that would mean the entire tank that holds the resin will shift sideways or tilt to break that layer free. That exerts quite a bit of pressure on the part, which can cause what we call explosions or tearing or warping or all kinds of bad stuff during printing. So on the latest printer, what we did was, see if I've got a better picture here. No, that's the best one. The bottom of the tank is under tension, a bit like a snare drum. So there's a little bit of flex and give in that surface. The laser moves on one axis across the entire area of the build platform. And wherever the laser is working, it's actually bumping up that bottom of the tank. This means that as the laser is moving across the platform, it's actually peeling really, really minute areas as it goes. This means there's way less total force exerted on the part at each layer, which means you can get better accuracy, better detail without kind of changing the physical properties of your part. As I just mentioned, here's just a little diagram of how that technology works. You have the tank where the resin sits. You have the part hanging upside down from the build platform. That's number 4 there. And then underneath, you have the laser. This diagram comes from the Form 2, where we had 2 mirrors that would direct that laser. On our current machine, it's just one that works in a single axis. We've got a lot of good documentation on our website about this if you'd like to see more and get some kind of more robust visuals into what this technology looks like as it's working. So what does the workflow for SLA look like? First, you need the 3D file. One way to get that is modeling a part through CAD software, whether it's SolidWorks, Fusion, Onshape, any number of good options. Another way to get parts is via 3D scanning, which is why Jose is here today to talk about that. There's a lot of ways to use 3D scanning, of course, so he'll go through a few of those options. After that, what you want to do is prepare the model in Preform. Preform is our free print prep software. You're welcome to download it, whether you own a Formlabs product or not. It's completely free, and it's what we use to accept an STL or OBJ file from whatever software you're using. You import that into our software. It supports the part. It orients the part in a way that thinks it is best for SLA printing, and then sends that file to the printer for printing. And then after that, obviously, you have some washing and some curing. I won't get too deep into this here, but part of the SLA process is that you've got some excess liquid resin on parts after the printing process completes, and it's important to wash that off and then give the part a final cure. Really quickly, again, I won't go through these one by one. We have a library of 30 plus, 35 plus materials at this point at Formlabs. We develop them all in-house for a variety of different purposes, depending on what sort of material characteristics you want to get out at the very end. Just really briefly, I'll roll through it. You got general purpose. These are your sort of basic, your white, clear, gray, blacks. You got rigid, which are super, super strong. Tough and durable, which mimic things like ABS plastic or polypropylene plastic. So they're really tough, but they've got a little give if that's needed. Flexible and elastic. So these are literally squishy parts. They're really cool. Let me just move my window here so I can see the rest. Specialty resins there on the end. So you got a high temp, an ESD or electrostatic discharge resin, and ceramic as well, which is really wild. Down the bottom, you've got our row of biocompatible resins. These are resins that have been certified by the FDA and other organizations to be able to be used with direct skin on skin or skin contact with a patient or a person in the medical field. And that includes things like long-term retainers, surgical guides, models, custom trays, all sorts of stuff. And then at the end here on the bottom right, we've got castable wax and castable wax 40. These are resins that have quite a bit of wax content in them, so they can be burned out of a mold for lossless wax casting, like you do with a wax model typically, but this is for 3D printing, which is really cool. Lastly, it wasn't on that previous slide, but I just wanted to call it out because it's relatively new. We've got a new material that's polyurethane, or what we call PU. It produces incredibly strong, robust parts that can be used for end use products. Something like this bike pedal, for example, could be used as a bike pedal by someone in the real world straight off the printer. It's a really amazing material. It has some printing considerations that are a little more extreme than our other materials. It requires a specific environment to use, things like that. But if it is what you need for your products, it's really, really amazing, and a delight to use and feel. Just a really cool material that we're really excited about. Moving over to SLS, or selective laser sintering. This technology uses a high-powered laser to do essentially what the SLA printers do for liquid, but for a powdered nylon powder. So a machine will deposit a very, very thin layer of powder on the top of the build area. A laser will shoot down from above, cure that layer of the powder. Then a sweeper will deposit another layer of powder, and it'll do it again and again and again until you get a completed part. Obviously, this is an SLS print, and you can see it's really, really strong and durable and perfect for a lot of product development applications. And because you can see this unrestricted section there, because the parts print suspended in that powder, any powder that's not being used in the print will still be around the part. The part is self-supporting and needs no additional support material. So we printed things like a full shirt of chainmail that just sort of unfolds out of the printer when it's done, because everything can sort of be supporting itself during the printing process, which is really, really cool. I'll jump over this one, but it's a similar sort of workflow to SLA. Produce a 3D file, prepare it in preform, prepare the fuse. There's a few additional checks there. Print your model, and then sift at the end. Very briefly, the sift is our negative pressure chamber that you use to filter out all the excess powder as you sort of do an archaeological dig on your print after it's over. It's really fun to do. You get this big block of powder that you have to sort of sift through and pull out parts. And so yeah, as I said, it's negative pressure. There's a vacuum attached to the system as well, which pulls any powder into a recycling system that can be used for another print rather than onto your floor. Quickly, I'll just roll through the available SLS materials at the moment. We've got nylon 12, which is a kind of all-around do-it-all material. We've got nylon 11, which is a stiffer material, good for high-impact parts. And then you've got nylon 11 carbon fiber for even higher strength. And then glass filled for even greater stiffness. So some of these materials I mentioned require the Fuse 1 Plus, which is a new iteration of that machine. But these are the 4 materials currently available for the SLS lineup at Formlabs. Bunch of different use cases for SLS as well: hobbies, product development, medical applications, functional prototypes, high volume production parts if you've got the kind of setup for it, all that sort of stuff. And then lastly, for me, just want to call out the software side of what we do. Like I mentioned, we have a piece of software called Preform, which prepares models for printing. It also has a really comprehensive stacking and packing algorithm for the SLS machine, the Fuse. So if you have a lot of parts that are kind of spread out, our software will automatically pack those into the smallest possible area while still giving them the best chance of a successful print, which is really cool. And with that, that's it for me. I'm going to stop my screen share and I'll pass it over to Jose. But thank you so much for your time and learning about Formlabs.
Thank you for tuning into this webinar preview from Formlabs. To view the content in full, please click on the link below. Alternatively, if you'd like to get more information on our products and services, then please visit our website.